Hi, everyone. Hi. So,
I have to admit something. Managing ML model development is messy
and unpredictable. That is especially for research-oriented teams that run a lot of experiments. In order to operationalize ML models, we need three things: reproducible model training, model traceability, and a single place of truth where all model-related information is stored and backed up and accessible to everyone in a team. Can everyone see my slides? Okay. So ML teams today are trying to address these issues by standardizing metadata tracking and by introducing naming conventions, folder structures, or branch naming. All of this is manual effort and is subject to human error. On the other hand, some teams built in-house tools or adopted an open source solution, only to learn the real cost of its maintenance when they are scaling their operations. My name is Prince Kanuma. I am a data scientist, technical content writer focused on AI, and I'm a developer advocate at Neptune.ai. After this session, you will know how to use Neptune to improve your individual or team's workflow and productivity as a researcher, data scientist, or machine learning engineer. In a perfect world, all metadata for experiments and models, like metrics, parameters, dataset information, or pointers to packaged models, are in a single place available to everyone on your team.
People can log,
Can display, can compare, organize, and query all model-related information quickly and easily. For every production model, there is a perfect lineage from training, right, that is reproducible, so you can trace back every model-related detail when you need to. And to get to that, you don't have to change your workflow or be locked into an end-to-end platform. You don't have to implement or maintain loggers, scalable dashboards, or databases. This is where Neptune comes into place. Let me tell you about Neptune. Neptune is a metadata store for MLOps built for research and production teams that run a lot of experiments. It gives you a central place to log, store, display, and analyze all metadata generated during the machine learning lifecycle. Individuals and organizations use Neptune for data versioning, experiment tracking, and model registry to have control over their experimentation and model development. This is what some of our customers say. Now, this is a small structure just to show you what Neptune is. And we are built with those three components: data versioning, experiment tracking, and model registry. And this is where things get even better. With Neptune, you can replace your folder structures, spreadsheets, naming conventions with a single source of truth where all model building metadata is organized, easy to find, share, and query. We want you to feel confident and in control of your models, experiments, by keeping record of everything that happens during your model development process. Now, It's infrastructure agnostic. You don't have to change anything in your infrastructure, and you don't have to change your workflow. This is how it works. In a nutshell, we have a client library that communicates with our database or metadata database, and that sends information to our dashboard where you can see, query, and compare data. Now, let's see it in action. So I prepared a demo for you, which is broken down in 3 parts. First is the basic example to get you started. Then we are going to dive into integrations with different softwares and frameworks, and a custom example to show you more things that you can do with Neptune. So first, let's have a look at a typical, a basic example in Keras on an MNIST dataset. And I'm going to show you what you need to change in this code to add Neptune to it. So here we have our parameters, dataset, and etc. So it's pretty easy to add Neptune to your code. Simply import Neptune.new as Neptune. Then you're going to create a run. That's the first step. You create a run. So in this run, I'm just gonna take this from my previous example that I already prepared. So it's going to be Neptune.init and then project. Inside our project, we have our workspace. I'll show you all of this in the UI. And we have our example project. So the name of the project is Keras example project. Keras example project. Then I already set up a user for this project that you don't really necessarily have to set up a complicated API token. So you just have to write here anonymous. Even if you're trying out, you can use this. And for tags, I'm going to use basic because this is our first example and it's a basic one. So here you initialize a run, and the first thing you can do is log your parameters. So all you need to do is do a run and then write here hyper parameters. And then you could just say equals to params, right? That's our first step done, logging parameters. And then now we have to look at our code. If we want to log our loss and accuracy, it's pretty simple. You only need 2 lines of code. So here we go. So run metrics. And this is the interesting thing. So you can create a folder structure using our hierarchical feature that creates a structure for you. You could define this just like this, and it's going to create folders. So it's going to create a folder called metrics, and then inside that folder, you're going to have losses, your loss. So, and in order to do your loss, you just have to use the log method that we provide you and just pass in your loss. That's it. Now you are tracking your loss. Now let's do for our accuracy. There we go. So now we just have to say accuracy, result. So that's it. That's all we need. And we can actually run this code and see it in the UI. Give it a minute. There we go. So you'll see there is a link here if you click on that link and open it, it's gonna open the dashboard. There we are. So now we can look at all metadata that we tracked so far. We have our hyperparameters. They are here, nicely displayed. And now here we have our metrics, and it's gonna have a structure. So inside you'll have your loss, and this is tracked live. So if you add more epochs, you would see this metric evolve over time. And okay, there we are. It's actually still tricky. So if you don't want to see it this way, you can actually smooth it out, and we can see that our loss is decreasing. And we could also see our accuracy. So that's our basic example. That's how we add Neptune to your code. It's pretty much 4 lines of code. And we have our hyperparameters and our metrics tracked. So now we also have a special tab where you can find all your charts. So if you add more charts, you'll find all of them here. And we have also resource monitoring. So you don't have to do anything for this. It gives you right out of the box. So this is easy, but we make it even easier and better for you by providing you with integrations where we had our data scientists identify the most important metadata in your favorite frameworks and libraries so that we can track them for you automatically just by adding as little as a single line of code. So let's look into that one. So this is our basic example. It's done. Now let's look at our integration. So despite, you still have to initialize your run, and all you need to do to add an integration is to, of course, import that integration. And you still track your parameters the same way. And what you need to do is to instantiate this here, pass in the run and the base namespace so that it can create a structure for you with this name. That's all you need. So it's even simpler than the basic example. And we have integrations with a lot of famous frameworks out there. You name it, PyTorch Ignite, and you can check that in the docs. So let's run this example now. Okay, it's running. We can click here to go to our dashboard again. There we go. So now we can go back to our metadata, and you will see metrics again, but it's a bit different now. So if you come here, you'll see batch. So we are tracking both your batch and epoch automatically for you. So just by passing that callback, it's already doing all of that for you right out of the box. You can see here that's still progressing live, and that's going to help you identify any problems. So if the loss starts to get out of hand, you can identify what's really happening. Instead of the traditional way, which is to save all of this into spreadsheets or to look here for the metrics that are displayed here and try to figure out, or just save the final metric and then try to figure out what happened during the training. So while this is training, we can explore our UI. So So now this is the run. It's the smallest unit we have. Inside the run, you'll find all your metrics and everything about your experiment. But that's not all that we want. We want to see the difference between different experiments and compare them and group them and identify them, tag them. Go to our main dashboard.
Here in the main dashboard, we have our tags.
Integration and basic. This is going to be useful. But first, let's look at what you can do here. First, we can add a column, of course. We can check the number of epochs. We can add number of classes. We can add the last batch accuracy. And those are going to be displayed here for you. Since it's still training, you won't see, the integration is still training, you won't see this displayed until it's done. So you can change the column colors, so you can easily identify whichever column you want. You can color code them. You can switch them around, switch positions with them, and organize them the way you want them. Then you can group by, which is, let's say you have you train 5 models using a specific optimizer, SGD, and then 5 other models you train them with Atom optimizer. You can actually group them by whatever metadata that you have that's important for you. So you can find out, so experiments using Atom were better than SGD, and so on and so forth. Then we have our search. This is where you can actually query around and see and find something important for you. In our case, we're gonna go for the tags. So we're going to put system tags, one off, and I just want the basic tags here. So now we identify all experiments that have the tag basic. And I'm going to save this as a view. And this view is going to be persisted here. Why do you want that? Let's say you have to present your research to a crowd of non-tech people like managers, and later you have a meeting with your data science colleagues. So using the views, you can actually separate predefined views for each of those groups. So you have the basic example. This could be for your managers, and you show them, okay, I want to show this column, because this is important to show the performance of my model. And then later on, you want to expose everything. You can also do that by creating a view that exposes everything for your more advanced and tech-savvy data science colleagues. So now we have our basic view. We can do another one just by doing the integration view. There we go. So now we can just jump between views and explain and show the view for each specific group. Now, I've showed you the basic example. I've showed you the integrations, which makes it even easier. But for me, there are more things that are important than just the loss, the metrics, and the hyperparameters. And I want to show you a little bit more of what you can actually do with Neptune. So now we're going to jump into our advanced notebook. So you do the same procedure, import the libraries, create the run, okay, so it's already created. Yeah, it's a bit empty now. So let's start by importing logging the hyperparameters. Then we have our data set. We're just going to initialize the data set. Now, I want to log the model architecture. That's very important for me. I want to be able to see my model when I go to the dashboard. So you can just instantiate your model, file name, and you have this here. But now, yeah, so now you're gonna save all of this into a text file. And just by creating a structure where we have our input and output files and artifacts, and you can just use upload method, passing the path to that file that you saved, and it's going to upload that file into our UI. Let's check that out. So now, there we go. We have our IO files, artifacts, and then we have our model architecture. Now that we log our model architecture, I want to log the loss and metrics. That's simple. It's the same steps. And after that, okay. And after that, you want to log some images. I want to be able to see my data set or my image and predictions. That way, okay, excuse me. Okay. All right. There we go. So, this was actually a good bug because now I can show you that you can resume runs. This is very simple. You just pass in the ID of your run, which is this last name here. You pass this ID as run into your Neptune init, and it's going to call that same exact run, and you can continue doing what you were doing previously. So, okay, let me give my hyperparameters, data set. Okay. All right. So now I want to log some images. This part here I already showed you previously, so let's skip that and get to the interesting part. So I want to save my images. It's pretty simple. All you need is to add this Neptune file as image and passing your image inside it, and that's it. The procedure is the same, and you have your images here. Okay. There we go. Voila. You have your images. You can add descriptions to these images. That could be your predictions or distribution of your predictions, and they will be displayed right here on the side. You could do so much, and it doesn't have to be just your test data. You could do this in whatever way. We don't really just tell you what to do. We give you the ability to do whatever you want to do. So after you log your images, for me, it's also very important to log my weights. So the architecture we already done. So I just want to log my model weights. And that's pretty simple. You just save your model weights and do that, and that's it. Okay. There we are. So right after that, you can go back and my model, you can see the saved weight files, and you can see all the variables saved here too. So finally, let's talk about notebook checkpoint. You've noticed that there is this Neptune symbol here. So we do also offer notebook checkpoint. And this, you can see it here. If you come to your source code, Here will be your usual, the script that you use to create the run. In that case, let me show you an example that we use the script. There we go. So you'll see that here we use the basic script and it's nicely displayed here. You can download it. And it's going to download that to your local machine. You can also, we also have our Git repository initialized here. So we find out whether your repo is, and we find out your last commit, and you can easily check out to that commit. So that's code snapshots. And now we will go to our notebook snapshot. So there we go. We have a notebook snapshot of the notebook that was used to create data here. And you can go to that notebook very, very easily. Or if you want to upload the latest version, you just say upload. And that's it. It's already set. You click upload checkpoint. And that's going to upload. And if you come to notebooks also, you could have a clear vision of that. And there's so much more that you can. And that's it. Any questions?
Sorry, technical question. Yeah, so Ganesh, you are asking, could you maybe show live examples of Neptune usability with comparison to SageMaker Studio? So I'm not sure if we have like SageMaker Studio presentation kind of like prepared to show you around. Let me maybe answer this question kind of like on the top level. So in general, the experiment tracking in SageMaker Studio is also there. So there is the large advantage of like it's being there inbuilt. So if you're already using AWS, especially if you're already using SageMaker, then you can use the experiment tracking inside the SageMaker, and that's pretty cool. With the Neptune, the main difference is the number of questions that you can answer with. So that's the first thing. So with the SageMaker, you can easily answer the question of like which model is the best, like our code does this approach work, like this type of questions. With Neptune, you can answer the same question, but also a bit more. Because you can log a lot of more information, so you can structure them in a different way, as Prince shown in the presentation. Like whatever the way you are thinking about your runs workflow, you can log that represented inside Neptune, and also you can log some additional data types like audio, video, interactive visualization inside Neptune. That's hard to do with the SageMaker Studio. And the second thing is that with the SageMaker Studio, it works very well with the AWS infrastructure. With Neptune, we didn't want to kind of like vendor lock you into kind of like specific training infrastructure, so we can use Neptune with any infrastructure, be it laptop, Colab, or any cloud provider. If you would like to expand your question, Ganesh, you can also request audio and video sharing and maybe ask.
Patricia is here, so she can take your email and then we can schedule a session, a one-to-one session with you and figure out your question, right?
Hanbao also is asking about the CI/CD example for Neptune. If you don't mind, Prince, maybe I'll take this.
Sure.
Okay, so let me share the screen. Okay, so first of all, Prince shown you this like very very flexible how you can log information to Neptune. So you can assign metadata in batch. Like you can assign single value. So I could do, like I have some additional parameters that I would like to log. Let's say this is okay, max epochs. Let's say I'm going to just write additional learning rate, so I can assign this information. I can also upload files through model, trying to upload my path to model. So this is the API for uploading. And the thing is that it's super simple to convert this to, you use virtually the same API for fetching the information. So instead of assigning, you just invoke fetch and assign this to the parameters, and you have your parameters fetched from the run. So for example, if you are like having a continuous training setup, that you have a model, this is like your best model currently, and you would like to retraining on a data set that includes some additional data point from the like recent days. This is the way that you can automatically just connect to the run, fetch the runs, all the runs, find the best one or the one deployed in the production, and like fetch all of those informations. And actually the training code, it's very easy to convert into kind of like this fetching retraining code. So here I can fetch the parameters. I can fetch just one value with a similar way. Similarly, if I have the upload method, I have the download method, which downloads the file either to the working directory or where I specify it. So this is kind of like the core building block that, like with this, you can configure any CI, CD, or continuous training setup. So like any information that you put into Neptune, you can very easily fetch. And second thing is that what Prince kind of like showed in a way by accident, is very easy to reconnect to run. So I actually have an example here. Let me have it. So here is a very kind of like one-on-one example of a monitoring run. So here I'm creating a Neptune run. I'm uploading some basic information like model information, and I'm going to just fetch the run ID. So this is this identifier of the run. Okay, I've created it. Let's say this is the moment where I deployed my model to the production. So I'm going now to stop. So this would be the end of your model deploying script. And now later on, let's say at the end of the first day, you've gathered some performance metrics, you've gathered some feedback from the users, you also, your model was running, so you also got some, you could measure what is the distribution of the inputs. So you can reconnect to the same run. We can see that if I run print structure, which kind of like shows in this hierarchical structure, you can see that I have this like model info hash version that I did set. So this is the same run. And I can upload the monitoring performance, and I can upload the histogram plot and kind of like stop it. So this was what would be the kind of like the continuous monitoring actually part would be. And as the time goes on, you would continue this every day. So with this example, and let's see how this actually works inside Neptune. So we see that this is running. Let's run this inside. So what I wanted to show you here is that, like it's very easy to reconnect to the run, upload some additional information, and kind of like keep all of this monitoring information in one place, or, kind of reconnect to the run to perform some, continuous tests. And this way you can, if you have the model, kind of like connect to it, calculate something. So we have here the production part, and we see here in the monitoring the input distribution, how does it change over time. So this is like a separate connection, and we can, for example, log images of the input distribution, so we see immediately what has changed. And also I'm logging the performance, and I can see on the step part, but I can also switch to time to see how it's changed over time, like over days, that type of thing. So with this hierarchical, with this like very read-write easy API, it's very easy to kind of like accommodate to any CI/CD setup. If this does match your use case, Han, that's I'm glad. If you have any specific like follow-up questions, post them on the chat, on the QA part, or request the audio and video.
There is another question. Is it possible to pick the region for the metadata storage? So please do me the favor.
Yeah, so there are two ways to deploy Neptune. One is the SaaS version, when we do host the whole Neptune instance. So your training occurs where your training occurs, and all of your information kind of like land into Neptune instance that is hosted by us. Currently, it's only one region available, and this is Europe. However, if data governance is very important to you. So if you have a strict requirement about that the data and any metadata about your runs, about your models should never leave your premise, it's also possible to deploy Neptune on-premise, on your own hardware, or inside your own cloud setup. So, like the access to it is very limited to within your organization. So this is also possible if data governance or some other regulations, especially if you're dealing with medical data, is an issue. This is also an option. Okay, I'm checking chat and Q&A. So far it seems we've run out of questions. Don't hesitate. Should we are here to like explain all of the nuances about the Neptune, maybe there is something more that you would like to see or for us to talk about. So if you have any questions, any doubts, just shoot. Thanks, Samuel. We are here. If you decide that you have any questions, we would love to answer those. Also, I have an open question to people, like if you didn't catch the first part of the presentation, let us know, and maybe we can redo and show the first part of like how to integrate Neptune with your code base, or with sorry, I got distracted reading the question, the message from Ganesh. So if you would like to show us the how to, if you did miss the first part and we would like for us to show the first part, don't hesitate, and we'll do that. Ganesh could ask about the GitHub example code. So that's the one. I'm also going to just share our like company-wide example. So there's also a lot of those. And if you have here it is. There's a lot of full examples about different use cases, different integrations. So that's that part, and there is also a page in our presentation, which I'm going to show in a second.
So if you want the examples that I showed today, they're here, and they will be merged into the main one later on.
There you go. I was just thinking, Prince, that maybe we can show a bit more how you can in-depth compare experiments, maybe on the TensorFlow Keras project with the comparison in-depth and the high plot.
The Keras example with the...
Sorry, how to compare in-depth runs, how you can compare in-depth runs between each other in Neptune. So kind of like going a bit in-depth on the Ganesh question about the like usability UX of like working with Neptune on a daily basis.
Okay, so let me... The Keras example, you're actually the owner of that project. I think I won't be able to show unless you add me to that project. That's why I created a new one. You could actually present that one.
Sure. So let me share this. I see also a question from Ganesh about the roadmap of Neptune. So I'll answer this in a second. So what Prince showed a bit kind of like briefly throughout the demo is that you can go into a lot of details. So not only you have the information about like, okay, like out of all of those models, which one is the best one? So, okay, I'm going to sort by accuracy, some additional filters, like, okay, I'm limiting to Keras, to my data set. Maybe I'm optimizing for mobile, so I would like to, filter by size of the model, that it should be below 50 megabytes or something like that. Or I would like to compare just my runs against Prince to see how, how the approaches that we both tried compared against each other and which one is the best. So this is the kind of like the base comparison, and you can do all of that inside this runs table. However, very often there are times like when you need to really go into detail. So what you can do is that you can select all of those runs and go deeper. So you can go here into horizontal split where you can access both of those. So I see the comparison here. I see the charts, and I can still add some additional neurons. But if I had more space, I can just full screen this part and see. So I see all of the charts here on the same plot, so I can really go in depth comparison. And the second part that is very cool is that if I have runs that already finished and some are that are still running, especially if my training is very long, I can see it here as it kind of compares. So, if my training is expensive and, the new approach isn't really optimistic, then I can compare it and say, okay, this is not going good. Let's kind of abort it and save resources for the other part. I can also go here with the side-by-side comparison, where I have not only the information that I have in the runs table, but I actually have all of the information available for those. So all of the parameters, all of the metadata here, I can compare in detail those run. And one of the recent addition is the parallel coordinates plot. We are using HiPlot under the hood. So maybe let's select all of the runs for this. So I'm going to select all runs, they are selected, and now let's go back to the comparison. So you see that there is a parallel coordinates plot, and I can where is the accuracy? Test scores accuracy. So I can see what runs, what parameters contributed to this particular accuracy. Narrow it down, all of the goodies that you would expect from the interactive parallel coordinates plot. So this is how you can in-depth compare runs against each other. And this is an example of a bit more advanced in-depth analysis that you can do inside Neptune with logging all of those informations. If you don't mind, Prince, I'll take the question about the roadmap.
Sure.
If you're new to Neptune, I hope that you like it. If you already used Neptune before, you may notice a bit of a change in how both Neptune is positioned and the accent of the features of what is it's going. And we see that Neptune started as purely this experiment monitoring tool, experiment tracking tool, but this is just part of the story. Typically, this is the most messy part of the experimentation part, but this is not the only part that we care about. And okay, let me stop sharing the screen. So, this is the part that is kind of in Neptune Okay, sorry, rewind. So this experiment tracking was like primarily a focus of Neptune some time ago, and we see that like the metadata that you want to store, like have under control, is a bit more just experiment. This is about the data versioning. This is about the artifact. This is about different use cases and being able to fluently move through from one to the other. So it's not about having a separate metadata store for the experimentation phase, for the production pipelines, for the continuous integration, continuous delivery. It's about having like one place for all of this metadata, and like this is where we want to move with Neptune fully. So the experiment tracking part is kind of like almost there. I would say it's always evolving. Like we see a lot of cool new frameworks and tools. So we are still kind of like adding a lot of integrations, making the comparison, like exposing more tools, more ways to do that. So this is the first part that's on the kind of like the most immediate future roadmap. So you've seen the charts comparison, you've seen the parallel coordinates plot, you've seen the in-depth parameter approach. There are also many other ways how you can compare runs. So one thing that is coming in the near future is customizable dashboard for the comparison, so we can compare experiments in a more customizable way. Like compare images against each other, plot the data points as a scatter plot. So different ways to look into the runs, into the comparison. The second thing is that with a lot of workflows, there is a lot of kind of like non-linearity. So sometimes you start the training in one script, you continue in the other, like you prepare the data, you prepare the features, you train, you evaluate. And typically with a lot of experiment tracking tools, this was not very well supported. And with the current Neptune API, it's very easy to do that. But we feel that we've just scratched the surface of this use case, kind of like multi-process logging, multi-script logging, combining information from different sources. So this is the second thing that it's there. And the third part is that you can already track a lot of information about the data, about the model, how does it perform on the production. But what is missing, and we've heard a lot from our users, and we see that like it's a very valuable addition to Neptune, is kind of like this. Knowing more in depth the lineage of your model. Okay, so this model, like what were the versions, like what model preceded this model on the production, this particular model, where did it came from, what was the data version, based on this data version, what model were trained, like how did they perform, what is the stage of this model, is it on staging, is it on like a dummy production run, is it already archived, or is it currently on a production. So kind of this model registry functionality, and also artifact storage, artifact versioning, and kind of like the lineage between all of those. So between the artifacts, between the model, and between the experiment. So those three things, or actually four, are kind of like the primary on our roadmap, with a lot of tiny bits and pieces, like specific integrations with frameworks, which we are adding on a not maybe daily basis, but more of a weekly, monthly basis. Okay. I see that some people left after the first part and after the Q&A session, and I also see some people that did join just recently. So maybe Prince, we could show once again like the demo part, the show around part of Neptune. How does it sound for people that joined recently? Kind of raise the hand or just wave on the chat and we'll do that.
Yeah, definitely. Okay, I'm going to restart.
Or shall we? Yeah.
But I'll skip the lengthy introduction. I'll just dive straight into the example. So I'm going to show you how it is Neptune to any experiment or any code you have. Let me share my screen. Okay. Let's start with a basic example. So, okay. Okay, let's start here. Pretty simple. There are pretty much 4 to 5 lines of code that you would need to add Neptune into a basic example without an integration. So it's pretty simple. You import Neptune, you initialize a run. You only need basically two things, but here we have 3, and I'll explain why. So we have our project. First comes the workspace, and then the project name, and the API token. This is pretty easy to get. The docs are have a pretty clear example on this. And then we have tags. These tags are just going to be there to help me filter through my examples. So after I initialize the run, let's say I have some hyperparameters here, and I want to log them. It's pretty easy. You just this is a dictionary style, right? Create folders. So let's say I want this to be under configuration. So it's what will this do is it will create the folder config, and then inside the folder config it will have hyperparameters, and then you will have our hyperparameters here. It's pretty simple. So if it's a static data, right, you could just use equals to, and then I'll show you how it logs series data like loss and metric that evolve over time. So here we just log our hyperparameters. That's done. That's what line of code, and you skip the model instantiation, and then you just simply come here where you have your loss and use our log method. This is used for a series of data. As you can see here, it says float series, string series, or file series. So if you have, float series, and then we also have our accuracy, which is also a float series. So we pass them into our log method, and that's going to track it automatically. Let me increase the number of epochs so that it's a bit different from the previous one. So that's it. That you only need to add Neptune run stop to stop your experiment, and that's done. Of course, in a .py file, but you don't need to do that. But it's also good to keep in mind so that you get the gist of it. Right, we're going to initialize. You'll see here there is a link, and you want to follow that link. So when you follow that link, it's going to bring you to Neptune. Inside, you'll find the run, which is the smallest unit we have. Run, you can see here it starts with the source code, where you will find the name of the file that was used to create this script, right? Wait, oh, I ran the wrong script. Okay. I ran the wrong script. So let me run this one. Module TensorFlow. Okay. All right, I just. Okay. That's one. Oh, okay. Now it's going to work. Sorry. Anyways, I will just use a previous one. It seems like my computer decided to give me the curse of a live demo. So if we come to all runs, we have here our basic example, which we use the tag basic. You can see here, we use the tag basic. From there, it created this run, and we can see by tag. So if I come inside this run, you see the source code, the entry point to this run was this file, basic.py, and that was tracked automatically. To track this, you could actually disable it. You can check the docs, and you'll see how to disable, tracking your scripts. And then we also have a Git configuration, like we track your Git configuration, where you'll see whether your repo is dirty. We find out your last commit, and then also we give you the option to actually check out to that last commit. So inside we also have resource monitoring. So if you had, I don't have a GPU on my local machine, but if I had a GPU, it will also track the GPU and the usage of that GPU. Here is tracking my CPU and my RAM usage. You also have some logs here. You get this right out of the box. You don't have to do anything on besides utils. So we also have our charts where you'll find all charts that you log. So if you add more metrics that you log here, you'll find everything in this charts tab. But the most important thing that we want to focus on is seeing everything that we tracked throughout our experiment. So first we tracked our hyperparameters right here, right? It creates this structure for you automatically. You just have to pass in the dictionary. Then we did metrics, and we just did a loss and accuracy. And as you can see, it logs all of your loss and all of the steps that are automatically for you. You just have to pass in the loss, just like I showed you. But then this is all great, but you still have to manually add a lot of things and your loss and accuracy. If you have more metrics, it will involve you writing more scripts for those metrics. That's why we have our integrations, where we data find out all the important metrics about that you care in an experiment with your famous frameworks like PyTorch, Keras, and a lot of frameworks the PyTorch ecosystem like FastAI, Catalyst, and Sacred, and etc. So you could actually just import integrations, and I'll show you how. This is the Keras example. So as you can see, you just have to do Neptune new, flow Keras, and you import the callback. So Keras uses callbacks to get data at certain steps of your or levels of your training. And we create this callback where we that you care about your experiment for you automatically. All you need after that, the previous steps remain the same. You initialize your run, and then you come here to your fit and just pass in as a callback. And inside that callback, you just have to pass the run that you created. This could be a resumed run. Run already later on, And then we have our base namespace, which is just the folder structure that you want to create. It's like the all of the metrics that are tracked from this callback are going to be stored. So I already ran this previously. So all I will do is come back and look for integration. So this is an integration. And as you can see here, hyperparameters remains the same, but we have now metrics. Inside metrics, we have our epoch level metrics, right? Your accuracy, your loss, your validation accuracy, and validation loss. So this was only a one epoch run, so that's why you don't see more data points. If there were more epochs, you would see all those displayed there. But now you can see in the batch accuracy how is it displayed. So you can see here in our accuracy, you can see our accuracy evolve over time, and each step it reached the peak. Also, we have our loss. We can see, okay, how is the loss doing? And since this is also displayed live to you, wow, once you start the script, it starts to log this for you automatically, and you'll see it live here, growing. Can't show because I just had that hiccup there. But this is going to help you figure out whether
You have a problem with your model.
so your loss could be growing, for example, which is not a good sign. And you'll say, okay, so why is it growing? You can actually find that out live instead of wasting all your compute or the price that you're going to pay for your compute by creating a run that's not relevant. You can stop the run just by checking your metrics live and say, oh, okay, so this is not going good, and you can stop that run right away and get to the bottom of what's going with your model. So that's integrations. It's pretty simple. It's just as little as a single line of code. Now, let's go into where you want to track more and metrics. You want to track your images. You want to track your model architecture. You want to track your model weight files. So that's pretty simple. The structure, you just initialize the run, track everything that you want to track, but this is where things get interesting. So instead of using your log, you can use our .upload and pass in the path of that file that you saved. So here I just saved my model as a text file, and I upload it to IO files, artifacts, and the name of my file, which is model architecture. We can check that out from the previous run I created. So there you go, notebook. And then if I come to IO files, artifacts, model architecture, I'll find my model architecture here. Now, model architecture is the first step. I want to log some images. You use, in this case, you don't have to convert them into, save them as JPEG and try to do that. You can take the actual tensors and use our Neptune types file as image. It's gonna convert that into an image for you automatically. This also works in PyTorch too. So we are logging the object straight into Neptune, and that's being images. If you come to test sampled images, you will find your images just nicely displayed here for you, and you can add a description or a name. You know, the sky is the limit to what you can do. And then finally, upload my weight files, and it's done the same way. You just use your upload after you save the model into your local machine, and then just use upload and pass in the path, and that's going to send that into Neptune. You can see here is in my model. So if I go back, come to, and then come to my model and find the save model, you can see here this is my save model wait files. So this is all cool. Let's say I want to get into a run and quickly get a glance of what that run was about. So I can create a custom where I can add a widget. And here I want to add all my charts. So this is going to be chart. And here my epoch. I want my epoch loss. I want my epoch validation accuracy, validation loss. And I want my batch accuracy and batch loss. And then I say add widget. Field is not present in this run. Which field? Okay. Wait. Need to charts. So add my first widget. Here I'm going to add my experiment. This is okay. Okay, that was the problem. I got into it the wrong. Okay. Integration. Okay. Yeah. So now we are set. Accuracy. There. This one's I only have one epoch. So let me show you if you have more. If you have, if we can do batch level too. So let's do a batch level, accuracy and loss. And you can actually display them side by side and see how they progress over time. Here is just because we only have one epoch, so that won't be displayed. So you could come into a dashboard like this that you created. You can add lots of other things besides charts. You could add images, image gallery. You could add single values, value list, and a file set, and etc. So that you can come into your run and just look at it and say, okay, I get what happened here, and that way it's you to understand your experiment at a glance. Now, I showed you how to log all that data, how to compare some of them. So if you come to charts, and I click in this beautiful eye here, all, it's going to display everything side by side for me. So there's one experiment at the batch level that trained longer than the other one. As you can see here, it's the blue and the yellow one, which is this one here, the integration number 4 and number 6. And you can see which one fared the best. Here too. Now you could also compare them side by side. So you can see, okay, which experiment is the best. You can have this side-by-side comparison. And if you want to go into a full table, you could also come here. And now we have a notebook here. And if you look at this sign here, this is the Neptune logo. So we also do notebook checkpointing besides code snapshots and Git. And if you come to source code and notebook snapshot, you'll see here a snapshot that created this specific run. And if you come to notebooks, you can explore more and compare notebooks and check out to a specific version. So you can see I had 3 versions. I can check out to any of these points here and continue working, or take after a colleague and continue working. Do is share. You could actually share this dashboard with anyone, your team mates, or anyone you want. You can just share the link and they can access this. Here in the main dashboard, now that we've seen the run, which is the smallest unit, you could see the overall dashboard where you could add columns. Here we're going to have our learning rate. We could have our accuracy, batch last, and the loss. So you could color code this as you wish. Have a preset of colors here, and you can move them around, right? But now you see here there's a search. I want to find out, I want to separate all my experiments into specific groups. So what you could do is to create, for example, I want to see all my integration experiments. Let's say one off and click on integration. And when I click done, it's only going to display me the integration experiments. Why is this useful? Let's say you're meeting with two different audiences. One is an expert audience. Your peers, your colleagues, they understand machine learning. But the other one, they just want to see the performance. These are your managers. They just want to see which model performs the best. So you can create persistent views to show, and you just click on save view after you create a specific query. You just click on new, and you can save that as a view. And that here, I already created this before, so we have our basic view where you'll find all experiments that have the tag basic, or you can go into the integration view where you can find all the experiments with the integration tag. And well, I guess that's it. You learned a lot today. Questions you would like to ask, feel free.
Would like to ask the question. On the right, there is a Q&A part where you can ask the question or just use the chat. If you prefer by asking it directly, you can hit this like request audio and video button. I believe that's how it's called. It's this blue button in the main. And we are here for you for the next 10 minutes. If you have any question to us about the Neptune, about what you've seen, so far, any other information that you would like us to share or show how to do things with Neptune, feel free to ask.
Yeah, and you can also schedule a one-on-one session with us. So feel free to, this is your chance to actually schedule a one-on-one session with us, and later on we can reach out.
If you would like to do that, you can head over to the people part. Then you can find the prince, because he will be throughout the whole event. And then when you click on the person, you can invite to the video call to immediately try to connect, send a message, or schedule a meeting. And then there will be a time slot for you to discuss in details more. Thanks, Ganesh, thanks, Emil, for the kind words. And thanks, Emil, for having us here at the MLOps event.
Yeah, thank you very much.
By the way, if you would like to play around to see some of the things that Prince shown today, if you head over to our documentation, like both in the docs and the example links from the page, you actually don't have to register to try out Neptune. Like there is an open space project which you can log your metadata there and like see around. So if you head on to any of our examples on the collaboratory, then you can like open the notebook, run it on the Google servers, and it will be logged to this publicly available project. So you can try how easy it is to integrate Neptune with your machine learning code, how easy it is to log the metadata there, and you don't need to even sign up. You can just log those there and see how that works, and if it lives up to the promise.
Thank you, Ganesh. Thank you, Ganesh, for acknowledging our blog. We've been working hard on the blog. I guess we are in the last few minutes. Questions, we are here. So, David, I see Priya, I see Roy. Do you have any questions, guys?
Okay, so I think we don't have any more questions. And thanks everyone for joining. And it was a pleasure to tell you a bit about Neptune. Hope it was useful, and happy tracking experiments.
Thank you, guys. Bye-bye.